All right, folks, it's Bass Action back in action. On this page of notes, we're going to look at my two favorite forms of a quadratic. Standard form that I did in the previous video is hands down my least favorite. So we're going to start with vertex form here, and its name implies the item that you get for free. Remember, I mentioned you always get something for free. So vertex form is, in fact, the fact that you get the vertex for free. So if we look at our form, remember this is minus an h and plus a k, so we can just read our vertex. Remember, we have to change the sign of the x value to make it a positive, but the y value can be read exactly as it is. So we've got our vertex, which means we can plot that. As I mentioned in the previous video, we can draw in our axis of symmetry, and we can write the equation for that axis of symmetry for that vertical line. Again, if you can picture the fact that this is an upward turning parabola, even from getting that vertex, you could automatically then read the fact that you know that's going to be a minimum, and you could answer that question. We could answer our range, recognizing it's going to go from that -3 up to positive infinity. And depending, again, on your comfort, you might even be able to answer this increasing and decreasing before you even finish off the rest of that graph. So let's take a look at the other parts once we get that. So we've got that vertex in there. We can get our y-intercept. So we can get this y-intercept by doing some algebra here. So if we want our y-intercept, we're going to let our x value equal 0, and we're just going to evaluate. So if I put a 0 into our function, I'm going to end up with a 2 times a 1, because I did a 0 minus 1 and squared it, minus my 3, gets me a nice y-intercept of a -1. If I have that y-intercept, I can reflect it across the axis of symmetry. Then I can also find my x-intercepts. This form is automatically set up for us. You can see my work here. It's automatically set up for us to be able to solve by square roots. So you can see I already moved the 3 to the other side. Then I'm going to divide by my 2. And then this blue is the next step, where I'm going to take the square root of every part. Then when I kick that 1 to the other side, now I've cleaned it up, I have my 1 plus or minus this radical 3 over radical 2. And of course, we know from our Algebra 2 classes that we wouldn't leave our answer like that. So when you look at my x-intercepts that I've written here, I've rationalized that. So I have my 1 plus or minus my radical 6 over 2. This is, of course, an awkward value to try to actually graph, especially if I don't have a calculator. So I did go ahead and pick another value. I picked an x equals 3, and I plugged it into my function, and I just found that at x equals 3, I got a positive 5. I did that mentally, and then I reflected it across. So I just did my 3 minus my 1, squared that times 2, and subtracted. The last little piece that I do want to talk about is, of course, our inequality here. We're looking for the places where our function is greater than or equal to 0. So where is it above the x-axis? And that's this portion and this portion, which means I want all the x values up to this x-intercept, and then all the x values to the right of the second x-intercept. I want these to be brackets because my inequality is inclusive, and I just write those intervals. My other favorite form is intercept form. This seems to be the one that students are the least familiar with. The intercept form means that they've given it to you fully factored. So the thing that we get for free are the intercepts, the x-intercepts. We can just read those and immediately write those as ordered pairs. So if I plot those two ordered pairs right away, I know that the axis of symmetry has to be halfway between that. So I could algebraically calculate that midpoint, or I can just count it out in this case and see that it's a 2. That gives me this 2, and it gives me the equation for the axis of symmetry. Based on the 2 of the axis of symmetry, that's the 2 in the vertex, so I evaluate. So I simply evaluated my function at a 2, and I got a 9. Now that I have that vertex, I can plug that in, and I can actually plot that point. And we're back to the discussion about the fact that that vertex, I can see, because it's a downward turning parabola, is going to be a max, so I can answer that question. I can now answer my range. Remember, it has to be written low to high, so I'm going to go from my negative infinity and stop at the vertex this time. And then I can also answer my increasing and decreasing values. The last little bit that we're going to talk about is our inequality. We want to know where it's above the x-axis, so that's this portion right here. So our answer is going to be the x values that are in between my intercepts this time, so from a -1 to 5, not inclusive because my inequality is not inclusive. So again, just like on the previous video, I went through this very quickly. I did glaze over a lot of the algebra. So pause, rewind, see if you can figure out where I got those numbers. If you can't figure it out, jot them down, bring me some questions in class or in SRT.